So welcome to recording number 8, lecture number 8, I believe. And we are going to continue with PowerPoint number 4 on the addition rule. And in particular, we are on slide number 4, which is talking about Venn diagrams and a pictorial way of representing probabilities, which we love to visualize as much as possible. So in the very top, we have two diagrams. Both of them have an A and a B. And the question is, which Venn diagram represents disjoint events? Disjoint means cannot both happen at the same time. So it's the one that has no overlap. So that'll be number 2. And now we have the Venn diagram here. And the question is to shade the region that represents A or B. As long as I'm happy with A or B, or both, then I would shade it. So which part of this Venn diagram would I shade if it's A or B or both? What would I shade to represent? I'm shading anything that I'm happy with. I'm happy with A.
The area of the intersect.
So say it again?
The area where A and B intersect.
Well, so you're saying this part here?
All of
Yes.
it.
Yeah, it would be all of it.
It would be
A or B or both.
A
all of it.
or B or both. Right? A or B or both. That means it's the part in A that does not overlap with B, the part in B that does not overlap with A, or both, or the overlap. Does that make sense? Yes? No? Maybe so?
Why couldn't it be just that section there?
Because the section that you, David, that you mentioned, which was the overlap part, that is the part that corresponds to requiring both A and B to occur. Right? I need both A and B to happen for me to land in that section, correct? But if I'm happy with A or B, then I don't need both. I just need one of them. So if I land here, then I'm happy because A occurred. And if I land here, I'm happy because B occurred. And if I land here, I'm happy because, well, both of them occurred, A and B. But I don't care if it's A and B. I just need one of them. Does that make sense? So, the Lori coming in clutch as always. Lori, boop, that's what I'm talking about. All right, superstar Lori, that's right. So, it says complete this rule. Oh, wait, then it says do the same for Venn diagram 2. So let's do the same for Venn diagram 2. If I have a second Venn diagram, and this one has my A and B non-overlapping, so they're disjoint, they have nothing in common, then where would I shade if I want A or B? Where would I
circles?
shade? Both circles, exactly. In this case, A or B, I'm happy with. I don't care if it's A, I don't care if it's B. As long as I get one of them, I'm happy. Okay? So then, it says complete the following rule. If two events are disjoints, like here, then the probability of A or B is equal to what? Now, of course, we're not looking for a number because we're not working with a specific problem here. We're looking for a nice formula. If shading represents probability, then the probability of A or B just becomes the probability of A plus the probability of B. In other words, it's this or that. If I don't care which one I get, just add them. So if I say, what's the probability of getting an ace or a jack? If I pick a card from a deck of cards, well, how many aces are there in a deck of cards?
4.
So what's the probability of getting an ace?
4 out of 52.
4 out of 52. What's the probability of getting a jack?
4 out of
4 out,
52.
4 out of 52. So what's the probability of getting an ace or a jack?
8 out of.
You just add them because there's 8 possibilities. So 8 over 52.
Professor, can I
Yes.
can I ask a question?
Yeah.
So the first Venn diagram, that one, if I were to write and or, I would put and under it, and the second one I would put or.
No, they're both ors. They're both ors. What distinguishes the two cases is whether or not A and B overlap. But in both cases, they're an or. It's just one there's an overlap, one there's not an overlap.
So when there's an and, where do they overlap or not?
Well, in this case, if I said, well, you know what, we'll get to and. Let's just not.
Okay.
Let's not do two things at once. We'll get to and. But right now we're doing or. Okay.
Is the plus and? Sorry, I know that's probably
no.
a dumb question.
Everything here is with the or. There's no ands.
Oh.
That's why I wanted to keep and separate. This is all the ors. Everything we're doing right now is an or. We'll do ands later. Okay, so or, this is all the ors. Overlap, non-overlap, but we're still or. It's just the math with an overlap is harder if it's an or, as we'll see in a minute. Not too much harder, but it is harder. Of course, I just read the question. Oh, okay, I'm sorry. So what I answered just now is the bottom question on page 4. If two events are disjoint, then the probability of A or B equal to probability of A plus the probability of B. That's the bottom of slide 4, the last question. I skipped one. Okay, I did skip the and question because I was really focused on the or. But actually, let's do that for a second just to get it out of the way. Angela, what's going on there? Oh, she can't even hear me. I guess someone is more important than I am. Okay, that's fine. I get it. I get it. So, what is the probability of A and B in this case here?
I can't see.
What's the probability in Venn diagram number 2? What is the likelihood of getting both A and B simultaneously?
It's not possible.
It's therefore, what's the probability?
0.
0.
0. When they are disjoint, you can't get both at the same time. If you can't get both at the same time, it's a 0 chance of occurring. Does that make sense? Seems reasonable, correct? I hope.
Yeah.
All right. No text saying, I'm not getting this or anything like that. So I'm hoping that means that it seems reasonable. Again, these formulas are specifically for the case where it's disjoint. We're not doing any of these formulas where they're not disjoint. We'll get to that later. It's harder. Okay, the math is harder, and let's not worry about it right now. We're focusing specifically where there's no overlap. The and is 0 because if there's no overlap, you can't get both at the same time. And the or is just one plus the other because, again, there's no overlap. When there is an overlap, things are more challenging. We'll get there. Let's look now at slide number 5. Okay, and on slide number 5, we have a Venn diagram situation. It says the circles in this Venn diagram show the proportion of students in a large class who got at least 8 hours of sleep last night, and the proportion who exercised at least 30 minutes yesterday. Is it possible to both exercise 30 minutes and get 8 hours of sleep? Conceptually, does that seem reasonable that it's possible?
Yes.
Yeah.
Sure, why not, right? So there should be some overlap, and in fact, there is an overlap. So suppose you pick a student at random from the class, find each probability below. First, let's not go in order. We're not going to go in order because the order that they have it there is not the simplest order to do it in. Or maybe it is, we'll see. Let's first do P of S, which is the second one on the left. The probability of S, the probability of S. What is S? S is getting at least 8 hours of sleep. So the question is, what percent of the class got at least 8 hours of sleep last night based upon this Venn diagram?
15%.
It is not 15%.
0.15.
At 0.15.
It's not 0.15.
Would you add 0.15 and 0.22?
Well, do 0.15 and 0.22 both fall in the S circle?
It would
Yeah.
be half.
So the S circle represents all the people who got at least 8 hours of sleep, not just the ones on the left. Oh, hello. Okay, whatever. Not just the ones on the left, but all of them, right? So it's going to be Patty, that was amazing. Who's Patty? And what was?
Me, the one that was talking.
Oh, hey, that was amazing. Good job. I don't know what
Thank
happened.
you.
You got the
What
right
did
answer.
she say? Patty, what did you say?
You got the right answer.
Oh, what's the right answer? I missed that.
Oh, okay. So you don't listen to me. Maybe listen to Patty. Patty, go ahead.
You add 0.15 and 0.22.
Correct. You add 0.15 and 0.22 for a total of 0.37 because S, when I say what is the probability of getting S, I mean all ways of getting S. And the 0.15 and the 0.22 both land in S. How about the next one? What is the probability of getting E?
0.22 plus 4.45, just like Patty would say.
Yes, just like Patty would say. And what does that equal to?
Not that quick. Hold on, please.
I'm not sure what you want me to hold. Okay, I got it. I'm holding on.
67.
67.
0.67.
0.67.
0.67.
Which is what? That's 67%, right? Correct? 67%?
Yep.
Okay. Now, we can answer two other questions pretty easily. Let's go to the top right. The probability of not S. What is the probability of not getting S?
0.45?
Well, is that the only way you can't get S?
Plus
0.45
plus
plus
18.
0.22.
No, 0.22 is still
Add
part
the
of S.
18.
add the 0.18.
Add the 0.18.
Add the 0.18.
Way to go, Patty.
So that's 0.63, right?
8, 9, 10.
I couldn't even
Yeah.
hit my button before they answered.
Say again, what was it?
I couldn't hit my space bar to answer before they answered.
Oh, so you're just a little slow. It comes with age. Don't worry about it. Happens to the best of us. Okay, so
Slam.
yeah, I'm talking.
It's all good.
So we have 0.63 is not S. By the way, there was an easier way of getting not S, wasn't there?
Well, yeah, you just work backwards. Wait, not backwards, but you could just like subtract.
Subtract what?
Subtract 0.45 minus from 0.67.
No.
Subtract
Which-
22 and 15 from 100.
Yes. We already have that S is 37%, right? We got that
Oh,
first.
but why 100? Sorry, this is so abstract.
It's got to add to 100%, right? You got to get
Oh.
one or the other, right?
Oh, okay.
So if S has a 37% chance of occurring, then not S is going to have a 63% chance of occurring.
So 100 minus
37.
37.
Two different ways of getting there. And how about the probability of not E? Using either technique.
0.33.
0.33, right? 0.15 plus 0.18 are the two possibilities of not E, or you can do 1 minus 0.67. Either way gets the same answer, correct? Does that make sense so far? Right, Venn diagrams are very...
Yes.
What was that? Okay, good talk. So Venn diagrams are very helpful to illustrate what's going on. Now, what about the top left? Actually, you know what? Let's start with the bottom left. It's a little bit easier. The bottom left, the probability of S and E. We require both S and E. Me too, Angela. I love learning new things. So what is the probability of getting S and E? How many ways are there of getting S and E?
0.22.
0.22. It's the overlap. The only way you can get S and E is to be in that little middle section, correct? There's no other way of getting S and E at the same time other than being in that little section. So that's 0.22. We agree?
Yes.
Okay, now let's get tough. Top left. Probability of S or E?
100. No.
None.
82.
Excellent. 82 what? Be more specific.
82%.
82%. S or E means you add up all ways. Remember, we did the shading for S or E, right? It's the same as that one.
Yeah.
You shade up the whole circles. Top left, middle, or left, middle, and right. For a total of?
82.
For a total of 82%. Now, the last two on the bottom right are tougher. Let's do the first one. The probability of not S and not E. So here's what I want you to do for this one. I would like you to make a new Venn diagram from scratch, 2 circles, S and E. And I would like you to shade in with vertical lines, not S, and then shade in with horizontal lines, not E. Okay, so I'll give you a couple second head start. So what am I shading for not S?
The E bubble.
Is that the only way you cannot be S? Is the entire E bubble not S?
And the
Except
box.
for the common spot.
Well, certainly not the common part, right?
Oh, good point about the box, though.
Is that all of not S?
No, you could do the universe too.
You can do outside. Just everything but S. Right? Do we agree that's not S?
Yeah.
What about not E?
The S bubble in the universe.
So
Or
the
box.
entire S bubble?
No, besides the common part.
Ah, well, I think I'd be a little more specific, right? So not E is this. And it's also, out here, correct? We agree?
Correct. Yes.
So if I want not S and I also want not E, which portion of the Venn diagram would I be focusing on?
Point
Point
18.
22.
Well, forget about the math. Let's do a visualization first.
Oh,
Which portion, describe it in words. Forget about math. Describe in words the sections of the picture. Let's not even use the word Venn diagram or circles. Just describe in words the section of the picture that would correspond to not S and not E.
The one without the lines. The part without lines.
No, just the opposite. Not S and not E means we want both conditions to hold, right? And this. So if one condition is vertical lines and the other condition is horizontal lines, and I want both to occur, then what am I looking for? What type of diagram picture would be the part that I'm after?
Where they intersect each other.
And what word would you use to describe that part?
what they have in common?
Right. So what word in English would you use to describe this kind of pattern where they overlap?
Graph, like graph paper.
Okay, it looks like a graph paper, right? It's got the vertical lines and the horizontal lines intersecting, right? I was thinking of the word grid, but what do I know? It's just the word that came to mind. Okay, so the part that I would care about would be all out here, but none of E and none of S, right? Do you agree? None of E or S is a grid pattern, right?
Yeah.
Am I losing you, or does this make sense?
You said none of E or S that's not a grid pattern.
Right, because I want not S and I also want not E. The only way to get not S and not E, i.e. to get neither one, is to be where in my diagram? What percentage?
22.
No, 22 is not. No, 22 is
0.18.
both S and E. We want not S and not E.
18%.
18%. We want the outside part.
Not S and not E.
Yeah, we
in
want
the
not,
universe.
well, the universe, you guys are using that term a little incorrectly. The universe is everything, not just the outside, right? The universe is everything. Because you guys are using the term universe to describe just the outside part. So I wanted to clear that up. The universe is your universe. It's everything that can possibly exist. Okay, but not S and not E means I don't want S and I don't want E. Well, if I don't want S and I don't want E, then that means I have to be in the outside part. And what's the likelihood of being in the outside part? 18%.
18%.
Agreed?
Agreed.
And then the bottom one, it says the probability of not S or not E. If it's not S or not E, then I'm happy with horizontal lines and I'm also happy with vertical lines, right? I don't care which one, not horizontal, vertical, either one works for me, correct? So what is the probability of not S or not E?
0.78.
Fantastic, 78%. Everything but the inside part. You look confused, Crystal. You have this look on your face like you're confused. No?
This seemed easier in algebra.
Well,
Now it seems like super complex. I don't know why. I'm just saying.
things are supposed to get more challenging, correct?
Well, I'm having to relearn, I guess. I didn't. Yeah. Anyways, everything.
Then
But
if you're like Angela, this is amazing because you get to learn something new every day.
everything.
And Isabella's with you. Kindred spirits all the way. That's what I'm talking about. Plus the silent majority.
Are we keeping you up?
Yeah, yeah. It's okay. It's for a good cause. It's for a good cause. Okay.
Sure.
Yeah.
I kind of missed the part where it says P not S and P not E.
Yeah.
I was getting the door, but so for the not S, is it everything except for S?
Yes, that's what not S means, right?
So with the middle part that does contain S, do we divide it by 2?
No. Not S means everything not an S. But that's not the only condition here. We also want everything not an E. So in other words, we
about the simpler one, the one above them. I like I said, I missed that. I was.
you want not S and not E, correct?
The 2 above that.
Just not S?
Yes, just not S.
Oh, well, what's S?
Is 0.15.
No, that's not S. That's only part of S. S is a whole circle.
So 0.37.
Yes, S is 0.37. So not S is everything else. So what's not S?
Oh, okay. I got it. My brain worked. Thank you.
Okay. Okay. So let's look now at the next page, slide number 6. We have to move forward because I have to finish this chapter today. So slide number 6. Okay. What happens? Okay, so we already did this one. It says the rule for finding the probability that one or the other or both of 2 events, we already wrote it here. P of A or B is equal to P of A plus P of B. Right? Correct? Yes? These words? Okay. So let's do a few examples to illustrate this. It says, show how to use the addition rule for disjoint events to compute these probabilities. It says if you roll 2 dice, find the probability you get a sum of 7 or doubles. If you roll 2 dice, find the probability you get a sum of 7 or doubles. Well, first of all, can you get 7 and doubles at the same time?
No.
No.
No. So they are disjoint. They are disjoint events. You cannot get both simultaneously. Because you cannot get both simultaneously, what we do is we compute each probability individually and add them. So do we know the probability of getting a 7? We did this probably in the first chapter, I think. You might have
That
forgotten
was
it.
a long time ago.
I know, 3 weeks. It's crazy.
A lot has happened in 3 weeks.
A lot. What's happened in 3 weeks? You haven't left the house once. What's happened in 3 weeks?
4 out of 36? No.
How much?
No, these are dice. There's 6 sides to the dice. It's 2 dice. It's 12. 2 out of 12.
No. First of all,
6 out of
David,
36?
David, the first die, how many outcomes are there?
6 outcomes.
Second die, how many outcomes are there?
6.
Fundamental rule of counting. When you have 2 events in succession, what do you do to those numbers?
You add them.
No, that's not the fundamental rule of counting.
Multiply them?
You multiply them.
Oh my God, yes.
So
6
it's
out of
36.
36.
So there's 36 possibilities. Now, how many ways are there of getting a 7?
6.
6. So what's the probability of getting a 7?
6 out of 36.
36.
Great. Now, how many ways can you get doubles?
36 out of 36.
Well, wait. How many ways can you get doubles?
12.
Count them. No, you can't get doubles in 12
Six.
ways. 6. Double 1s, 2s, 3s, 4s, 5s, and 6s. Only 6 ways to get doubles.
But you have 2 dice. Why is that hard to understand? Wait, you have 2 dice.
I don't know. Yeah, you can't get doubles with 1 die.
You're like, I don't know.
You can't get doubles with only 1 die,
No, that's true.
right? So it's the fact that you are rolling 2 that allows you to get doubles. So let's look at all the possibilities, right? What are the different ways you can get doubles? 1s, 2s,
1s,
3s,
2s,
4s,
3s, 4s,
5s,
5s,
6s.
6s.
So how many ways are there of getting doubles?
12. No,
6.
6.
6. Right? 6 out of 36, correct? So in overall, what's the probability of getting a 7 or of getting doubles?
12
It's
out
the
of 36.
judgment-free zone. No judgment here. Okay, we're all struggling. We're all working. We're all trying to learn. And as long as we
And not
learn,
to
we're
mention
happy.
it's 2:30 in the afternoon.
Does that help or does that hurt?
I think it's a good thing.
Not if you've been up since like 4 or 5.
Why would you be up at 4? Why? Okay, the sun's not even up yet then.
Lori, we don't judge you.
A day.
No, I'm judging that. Why do you get up at 4 in the morning?
I can't
Gotta
sleep.
get that homework done.
Wow, if I get up before 10, it's a horrible day. Crazy, too much.
Have to
All right.
pack a lot in a day.
I hear that. Okay, anyway, back. Okay, so where the hell was I? All right, so what is the probability of getting 7s or doubles?
12 out of 36?
12 out of 36, because you add them together. Correct? 6 out of 36 plus 6 out of 36. They are disjoint, so all you do is add them. 6 out of 36 plus 6 out of 36 is 12 out of 36. Correct?
Okay, I'm sorry. Can you go back up to like, oh, I see. So if you put it in the addition rule, A is like doubles, B is like 7s. Okay.
Okay. Next question. If you pick a card, what is the probability that you get an ace or a jack?
Well, there's 4 jacks and there's 4 aces and there's 52 cards. So 8 out of 52. What? Forget it. I don't
Oh, Lori.
What? Crazy talk.
Yes, Lori,
I'm
you
ready
did
for the
that.
8 out of
I'm ready for the
52.
next math. Bring
Okay,
it on.
next math. Let's do it. Next slide. Okay, here we go.
Lori.
Slide number 7. Here we go.
I feel like I'm part of an experiment.
No, we are so proud of you.
I am. Okay, so now that's it for the easy cases. That's when it's disjoints. Those are the easy cases. Now we got to worry about when they aren't disjoint. These are a little tougher. So we'll do an activity to lead in to help us understand where the formula comes from. So we're all on slide 7 now. It says a bowl contains 4 green M&Ms, 6 red M&Ms, 7 blue M&Ms, 3 green Skittles, and 5 red Skittles. That is my lunch. Okay, that's
I'm
what.
just gonna say I need my candy here.
That's amazing. That's like the best meal ever. Anyways, well, except for orange creamsicles, they are still my favorite ever. But that's besides the point. So the question is, what is the probability that it is green, or that it's an M&M? So many nutrients. That's right. You get all 5 of the major food groups. You get chocolate, you get sugar. I mean, I don't know what the other 3 are, but you get them all. Anyways, what's the probability that it's green or an M&M? So here's the thing. We have to consider all ways that it's green. Correct?
So 7.
So let's see. There's 3 green Skittles, and there's 4 green M&Ms. So there's 7 ways that it can be green, right? Correct?
Yes.
Okay. Now we have to consider all the ways that it can be an M&M. How many ways can it be an M&M?
17 ways, because it can be green, it could be red, or it could be blue.
Correct. 17 ways, right? So 4 plus 6 plus 7, that's 17. So we have 7 ways that it could be green and 17 ways that it could be an M&M for a total of how much?
34.
7 plus 17?
4.
24, sorry.
24, right? However, there's one problem with that.
It will be never.
Who can tell me what the problem is?
It can't be both. It
No.
can't be an M&M and a Skittle.
No, but that's not what we're finding. We're finding M&M or green. Right? That's what we're
Well,
looking for, right?
Well, you can't be a green M&M and a green Skittle at the same time.
That's true. Of course not. You're 100% right. But that's not what we're focusing on. We're focusing on green, and we're focusing on M&Ms. How many ways could it be green? 7. How many ways could it be M&Ms? 17. When I asked you to add them, you got 24. But 24 is not the answer.
There's an overlap.
There's an overlap. There's an overlap.
You have to subtract it.
There you go. Because you can be both a green and an M&M, can't you?
So I might just have to make the Venn diagram just to get through this.
That's
Yeah.
fine. Huh?
So the answer is 20 because we're subtracting the 4 green M&Ms?
The reason why we're subtracting the 4 green M&Ms is because we counted them twice. You counted them for the green, and you also counted them for the M&Ms, right?
So you have 24 ways, but that's not right because there's 4 green M&Ms, so you have to subtract that.
So you have to subtract the overlap.
Oh, 4 is the overlap. Oh, okay.
Right? 4 is the overlap, correct?
Overlap. Okay, so now it's 20.
So now it's 20 out of how much? So for that, you just got to count how many there are altogether. 10, 17. How many are there altogether?
25.
There's 25 pieces of candy, right? Correct?
Yes.
So what's the final answer?
20 out of 20.
20 out of 25.
20 out of 25. That is the probability of getting a green or an M&M. And if you go to the next slide, they have the updated formula. The probability of A or B is you count all the ways of getting A, you count all the ways of getting B, but because you double count some, we have to subtract all the ways of getting both. Because the ways that you got both appeared twice. The ways that you got both appeared both in A and appeared both in B. Does that make sense? So the new probability rule, the general case, the case that works for all situations, whether disjoint or not disjoint, is that you calculate how many ways you can get one, you calculate how many ways you can get the other, you add them, but then you calculate how many ways you can get both and you subtract that. Let's do an example, write a following. We want to know the probability of getting a sum of 10 or doubles. A sum of 10 or doubles. And we'll do this by actually writing it out. How many ways are there of getting doubles?
6.
6.
1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. How many ways are there of getting a 10?
3.
What are they?
5 and 5.
5, 5.
8 and 2.
Not when you roll dice, it ain't. I'm not sure what
I'm
dice.
sorry. 7 and 3.
I don't think it's 7. I don't think your dice have 7 either.
6 and 4. 6 and 4.
Sorry.
And then any other way?
4 and 6.
4 and 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9 ways, correct?
Yes.
No.
With
Oh.
one overlap.
One overlap. We already have 5, 5. We have one overlap. So we can't count it twice. We got to cross them out. So what's the total amount?
8 out of 36.
8 out of 36. Ready? Make sense?
Yes.
Oh, yeah.
Okay. Does the addition rule work even when the events are disjoints?
Yes.
Yes, because what's probability of A and B when they're disjoints?
A and B.
No, what's the probability of A and B when the events are disjoint?
Oh,
0.
yeah.
0, right? It's 0. You can't have both, so it's 0. So it goes away anyways. Make sense?
Sure.
Okay, let's do the next slide. This is slide number 9. It says, you will be assigned to observe a student chosen at random from a 3rd grade classroom. In this classroom, 80% of the children are English learners or receive free reduced price meals. 40% are English learners and 50% receive free reduced price meals. Compute the probability that the child selected is both an English learner and receives free reduced price meals. So I'm going to give you 2 minutes to try this yourself before I jump in with the answer. So who here thinks they have it? So this is a little challenging, a little more challenging. So we have a Venn diagram. First, I was covering the chat, so it's possible somebody did have the answer. Let me check. No, nobody did. Okay. So let's see what we have here. We have English learners as E. And then we have reduced price meals as M, correct? What percent are E?
80.
80%. But do we know which part of E that is?
40%?
How do you know it's half and half? Did they give me that information?
No. I mean, down here it says 40. Hold on, you're covering my slide. It says 40% are English learners and 50% receive free reduced.
Not mine. Mine says 80% are English learners. Are you
That's why I don't get the math, because if we base it off of the percentage that they give us, it's 90%, not 80%.
I know. Hold on. We have to interpret it. 1 second.
Oh.
80% are English learners, correct?
Mm-hmm.
So that means that this entire circle is 80%. But I don't know how much is here and how much is here yet. I haven't gone that far in the problem. I just know that the entire circle is 80%, correct? Yes, no? Everyone?
Yes, yes.
And we also know that the meal part is, oh, I'm sorry, I misread the question. Start again, I apologize. Sorry. It says 80% are English or receive free price meals. So that means that all of this is 80%. English or free price meals. So what part can I label if 80% is English or free price meals?
The little shaded part. I mean the middle part.
No. Or, what does or mean?
All of it. Except for what's outside the circles.
And therefore, what's outside the circles?
20%.
Okay, so all we know so far from that one line is that 20% is outside both. Correct? Yes?
Yes.
Yes.
Okay. Now, we also know 40% are English learners. So that's, and Yesenia, I'm sorry. I think that's what you were referring to earlier when I misread the question. I apologize. But 40% are English learners, but that 40% is anywhere in the circle. Here and here. I don't know which part is which yet. I just know that this part here is 40%. And I know also that 50% are reduced price meals. So this circle here must be 50%. Does that make sense so far?
Yeah.
To me.
Not to you?
You know what I tried to do first? I tried to set it up in the problem, but that I guess wasn't wrong. I mean, that was wrong.
Right, you first have to recognize what's going on.
But isn't just, was I wrong? And that's the part that you subtract, the 40 and the 50? And
Well,
this is all anyways.
I haven't gone that far yet. I'm just labeling things right now.
Okay.
Right now, I'm just labeling things right now, correct? The first part told me that the inside part was 80%. So all of this is 80%. And 20% out here. E is 40%, M is 50%. But as the Senate pointed out, 40 plus 50 is 90, not 80. 40 plus 50 is 90, not 80. So how do I alleviate this issue?
Do you have to find
Nope. Don't have to find anything. It's right there already.
you have to take away 10% to make it equal 80?
Okay, so why do I need to take away 10%? Because it must be, go ahead, you got it.
It's the middle portion that's 10%?
Yes. The middle portion must be the 10%, leaving 30% here for a total of 40, 40% here for a total of 50. So now we have 80%, 20%, 40%, 50%. All the conditions are satisfied. Because it's the double part, it's the overlap that we count twice. When you do 40% and 50%, you're not taking into account that there's an overlap. So because you're 10% off, it must be that overlap was 10% off. Does that make sense, Lori?
So just in reading, wait, compute the probability. Oh, wait, you will assign. So you have 80% of the children are English learners or receive a 40% are English learners and 50% receive free. Oh, we haven't got that. Oh no, how, wait. Oh, meals, 50%. Compute the probability. That's the one you just answered, right?
Yes.
The 10%?
Yeah, so it says compute the probability that the child selected is both an English learner and receives free reduced
Whatever's in both.
Whatever's in both will be 10%.
Professor,
Okay.
so if we ever have a disparity in our equation, like for instance, this one's telling us 80%, but when we add both percentages that they give us, it was 90. So whatever the disparity is what we're subtracting in our equation?
I mean, if the problem is like this, then yes. I don't want to make a blanket statement that would hold for every possible situation, but certainly if the problem was like this, then yes.
Okay.
Okay.
So you don't, it didn't really have anything to do with that addition rule.
No, it's the new rule that says that you have to subtract off the overlap. Right? The addition rule says the probability of A or B, it's probability
The
of
addition rule right here, right?
Yeah.
And then that, how we got 10% was this part, right?
Yeah, we got 10% because the probability of A or B was 90%. Sorry, was 80%. The probability of A was 40%. The probability of B was 50%, minus the probability of A and B. So we used the addition rule, but we used it more from we used it more from the Venn
Visually.
diagram than we did the
Yeah.
math.
Okay. I like visually.
Does that make sense?
Yeah.
Any questions on this stuff? Okay, well, we finished PowerPoint number 4. It's a small homework on this one. So it's due in a week. By due, of course, you're not handing it in. What I mean by due is, just, make sure you understand it in time for a quiz if we have one. Again, remember, we're having a quiz on Tuesday of next week. That quiz will be on Chapter 3 or PowerPoint 3. And then we might have a quiz on 4 on Thursday of next week because we're supposed to have lots and lots and lots of quizzes. And now we're entering going to be the 5th week next time, and it's only our 2nd quiz. So, and we'll probably have a test roughly soon because I'll have to check what the 5th chapter's like, but we'll probably have a test in a couple weeks, I would say. Does that sound like a good time to have a test? Yes, no, maybe so. We'll talk about it. Tests are a necessary evil. Anyways, that's it. We're done for today. So we'll end a few minutes early. I'm going to stop the recording.